Hello students, in this video I'll discuss about DC motors practice questions. We'll start with the DC motors practice questions. So before we to start with the practice questions of DC motor, DC motor will convert DC electrical energy into output mechanical energy. So input is DC electrical energy, output is mechanical energy, is nothing but what? Rotation. So here DC motor has same like DC generator construction. We have armature winding and field winding, and armature winding is placed on the rotor, and field winding is placed on the stator. Same like DC generator, field winding is placed on the stator. So whenever input power supply is given to the armature winding, so this power supply is given to the armature winding through the commutator and through the brushes. First power supply is given to the brushes, and then it goes to the commutator, and the commutator will convert DC power supply into AC power supply in case of DC motor. And then whenever this armature conductor starts rotating in the magnetic field, it cuts the flux provided by the stator winding. Then EMF is induced in the armature winding. That EMF we call as a back EMF. It opposes the input supply voltage. Now let's start with the practice questions. First question: the direction of the rotation of the DC motor can be determined. In the DC generator we use Fleming right hand rule, but in the DC motor we use the Fleming left hand rule. So answer is B. The current flowing through the armature conductor of a DC motor. See, to the DC motor actually we give DC power supply, but that DC is converted into AC with the help of commutator or slip rings. So this AC current will be there in the armature conductor. So current in the armature conductor is nothing but what? AC. So answer is C. Next, EMF induced in the armature of a DC motor is, just now we have discussed, whenever DC power supply is given to the DC motor, whenever rotor started rotating, this rotating armature conductor cuts a flux, then EMF is induced in the armature conductors. So that EMF is known as back EMF. So it is known as what? Back EMF. So what is a back EMF formula is, we have back EMF formula, we have V is equal to EB plus IRA. This is a voltage equation of the DC motor. So this EB is equal to, what is the formula? EB is equal to V minus IA RA. So and one as like DC generator, the EB formula again same thing, pi Zn by 60 into P by A. Right, this is the back EMF, and EMF induced in the DC motor armature conductor is known as what? Back EMF. Next, the value of the back EMF in a DC motor is maximum. When the back EMF value is maximum is asking. So just now we have discussed back EMF formula, pi Zn by 60, pi Zn by 60 into P by A. That means from this we can analyze that back EMF is directly proportional to the speed. So when the speed is more, back EMF will be more. So DC motor is maximum when the speed is maximum. When the speed is maximum, as the load increases, speed is going to decrease. As the load increases, speed is going to decrease. So speed has to be maximum means load has to be less. That means under no load condition, speed is more. Speed is more means back EMF is more. So answer is A. Under no load condition, back EMF in the DC motor is maximum. Next, the input power supply terminals. The input power supply terminals for a DC shunt motor are reversed. When the input power supply terminals of the DC shunt motor are reversed, then what will be the effect on the motor? So motor will start runs in a reverse direction. Next, the magnitude of a force acting on a current carrying conductor in a magnetic field is independent of, what is the force on the current carrying conductor? F is equal to BIL. So flux density, current and length of the conductor. Depends on flux density, depend on length of the conductor, depending upon current flowing through the conductor. So it is not going to depend on the cross sectional area of the conductor. So correct answer is C. So force on the current carrying conductor is not going to depend on the cross sectional, is independent of the cross sectional area of the conductor. When a DC machine is connected in the DC supply main, it will produce. So whenever power supply, DC power supply is connected to the DC motor, so some EMF is induced in the motor armature conductor which opposes the input supply voltage, that is called back EMF. So it is correct. And DC motor will produce unidirectional torque, and copper losses will occur in the windings. So all the options are correct. So answer is D. Next, Fleming left hand rule is applicable to, as just now we have discussed, it is applicable to DC motor. Fleming right hand rule is going to applicable to DC generator. So Fleming left hand rule is DC motor. The armature current drawn by the DC motor is given by Ia is equal to V by Ra only when. So usually in case of DC motor, what is the voltage equation of the DC motor is V is equal to EB plus Ia into Ra. So from this I want armature current Ia is equal to V minus EB divided by Ra. Ia is equal to V minus EB divided by Ra. So what is asking is this formula has to become just V by Ra. That means this back EMF EB value must be 0. So under what condition back EMF becomes 0? So back EMF depends on the speed of the motor. When the speed of the motor becomes 0, back EMF becomes 0. When the speed of the motor becomes 0, when the motor is under the standstill condition, motor is at stationary condition. So answer is A. Next, the armature power developed by the motor in DC motor is given by, so armature, in the armature, what is the power formula? Usually the power formula is V into I, but in the armature, so armature means armature voltage developed in the armature is EB and the current in the armature is IA, EB into IA. So answer is B. The back EMF in a DC motor, it opposes the applied voltage. So it opposes applied voltage. Answer A is correct. Next, motor starters. Motor starters are essential for avoiding the excessive starting current. So in the DC motor we use starters. What is the purpose of the starter? Let us understand. Armature current drawn by the motor, what is the formula? V minus EB by Ra. So whenever we switch on the power supply, initially motor speed is 0 or motor speed is very less. So motor speed is 0 means what? Back EMF is equal to 0. So this subtracting value is becoming 0 means V by Ra. So this V by Ra will be huge. So this V by Ra, this armature current is going to be large current. V by Ra is going to be large current. It will damage the motor windings. To restrict this starting large current, we use some additional resistance. That additional resistance is nothing but what? Starter. So the purpose of the motor starter is to avoid the excessive current in the motor during starting condition of the motor. So answer is what? D. The armature torque of the DC shunt motor is proportional to. So we have one formula. So what is that formula is T proportional to pi Ia. This is the usual torque formula. So here I will write three formulas, general very important formulas in the DC motor. T proportional to pi Ia, that is first formula, and second formula is speed equation of the DC motor, N proportional to EB by pi, and third equation in the motor is V is equal to EB plus IARA. V is equal to EB plus IARA. And fourth equation is armature current Ia is equal to V minus EB divided by Ra. Very important formulas. torque proportional to pi Ia, speed equation of the motor N proportional to Eb by pi, and voltage equation of the motor V is equal to Eb plus IRA, and armature current Ia is equal to V minus Eb by Ra. By using all these four equations, entire DC motors we can easily analyze. Now, let us see the question now. The armature torque of the DC shunt motor proportional to what? So T proportional to we know pi Ia. But in case of the DC shunt motor, flux remains constant. DC shunt motor is a constant flux motor and also called as constant speed motor. Flux is not going to change. Therefore, T proportional to what? Armature current. So, in shunt motor, the torque is proportional to armature current only. The answer is what? A. This is the answer. Next, torque developed by the DC motor depends upon current flowing through the conductor, magnetic field and active length of the conductor, number of conductors and radius of the armature, all the above factors. So torque developed in the motor, torque developed by the DC motor depends upon what factors? Force acting on the conductor, we say F is equals to BIL. So it depends upon the flux density, current as well as length. So answer is torque developed by the motor also depends upon the here don't take this formula, T proportional to pi Ia and T is equal to K into pi Ia. This K value depends upon the number of conductors and as well as radius of the armature. So the answer is D. Next, which of the following motors should never be started on no load condition? So series motor should not be started at no load condition, because under no load condition the speed of the DC series motor is going to be dangerous speed. So speed is going to be infinite. So if we start the DC series motor under no load condition and it runs with the dangerous speed. See, N proportional to EB by pi. Under no load condition, current drawn by the series motor is very low and flux developed by the motor is very low. This denominator is very low means speed of the motor will be infinite, large. So that will damage the motor. So series motor should not be started on the no load condition. Next, the starting torque of a DC shunt motor. The starting torque of a DC shunt motor is low. So T proportional to pi Ia for shunt motor. For shunt motor, T proportional to pi Ia, but flux is constant. So T proportional to Ia. But whereas in series motor, T proportional to Ia square. So large torque will be developed by the series motor and low torque will be developed by the shunt motor. So answer is B. A series motor has a relatively high starting torque. So just now we have seen for series motor T proportional to Ia square. Therefore it has high starting torque. High starting torque. Next, the torque developed in the DC motor based on what condition? The torque developed in the DC motor Next, the formula for the torque developed by the DC motor is T proportional to pi Ia. If I remove the proportionality, we will get some constant. T is equal to K into pi Ia. K into pi Ia. So answer is A. No load speed of which of the following motor will be highest? Series motor speed is going to be highest. Series motor speed is highest. The eddy current losses are directly proportional to F square, frequency square. Next, the iron losses. So core losses are iron losses, eddy current losses are hysteresis losses, all the above losses are iron losses. So answer is D. 3-point starter in DC motor is used to limit already we have discussed starter purpose is to limit the current, to limit the starting excessive current in the motor. Next, the direction of the rotation of the DC shunt motor can be reversed by, so torque proportional to pi Ia. So how can we reverse the torque direction? Either by reversing the field winding terminal or reversing the armature winding. So answer is either field or armature. So answer is D. The speed of a DC motor can be controlled by changing. So already we have discussed speed of the DC motor is n proportional to EB by pi. So that is EB is equal to V minus IaRa divided by pi. Speed of the motor by we can change by changing the input voltage or by changing the armature winding resistance or by changing the field winding. The speed of the DC motor can be controlled by changing flux, by changing armature circuit resistance, by changing applied voltage. So answer is all the above. Next, series motor used for dash applications. Series motor is used for high starting torque applications. Answer is D. Application of the DC shunt motor. Shunt motor cannot be used in cranes, cannot be used in hoist, cannot be used in trains. It can be used in driving machine tools. Answer is A. Next, for constant speed applications, which motor is preferred? We prefer DC shunt motor. DC series motor is most suitable for cranes. Cranes require high starting torque. When the speed of the DC motor increases, its armature current. So let us see 34th question. When the speed of the DC motor increases, what happens to armature current? So what is armature current formula? Ia is equal to V minus EB divided by Ra. Now what is saying? Speed of the motor is increasing. Speed of the motor increases means back EMF is going to increase, because when the armature is rotating at high speed, flux cutting will be more and back EMF will be more. So this subtracting value is more means total value is going to be less. Armature current is going to decrease. When the speed of the motor increases, armature current is going to decrease. Answer is B. Now let us start with some previous year questions now. EV by V ratio of a DC motor is an indication of its. See, EB divided by V. EB nothing but back EMF of the motor. This back EMF is developed in the motor because of the rotation of the motor. Rotation is nothing but mechanical power, output power of the motor. So this is output power and it is input power indirectly. So output power by input power is nothing but what? Efficiency. Answer is A. Next, carefully see this. Which of the following statements are correct for DC shunt motor? Speed of the DC shunt motor is sufficiently constant. So 1 is correct. For the same current input, its starting torque is not high as that of series motor. Yes, DC shunt motor starting torque is not that much high when compared to the series motor for the same current. That is also correct, because for shunt motor T proportional to Ia, for series motor T proportional to Ia square. For same current, series motor torque is high, shunt motor torque is very less. Third point, the motor can be directly coupled to load such as fan whose torque increases with the speed. So this is not correct. The motor can be directly coupled to the load such as fan whose torque increases with the speed. No, it's not correct. So 1 and 2 are correct. 1 and 2 are correct. Answer is C. The yoke of a DC machine is made up of what? Cast steel. Next, if the field current of a DC shunt motor is changed, then if the field current of a DC shunt motor is changed, then torque remains constant but output power will change. So torque T proportional to what? Pi into Ia. Field current we are changing, that means flux we are changing. So flux changes means torque is going to change. Power P is equal to, what is the formula? EB into Ia. Power is not going to change, power remains constant. Power remains constant but torque will change. So both the torque and output power will remain constant. So torque will change but power remains constant. Power remains constant, torque will change. Answer is B. The back EMF in a DC motor. So already we have discussed V is equal to EB plus Ia into Ra. This we can write it as V minus EB minus Ia Ra is equal to 0. You see V and EB both are in opposite polarity. So back EMF is going to oppose the applied voltage. Answer is A. Next, if the load on DC shunt motor is increased, its speed decreases primarily due to load on the shunt motor is increased. So when the load on the shunt motor increases means speed is going to decrease. Speed decreases means back EMF is going to decrease. Once again, if the load on the DC shunt motor is increased, because of what? If the load on the DC shunt motor is increased, its speed is going to decrease. Then due to what condition? When the load on the motor increases, current taken by the motor is going to increase, and and back EMF is going to decrease. Because of the back EMF is going to decrease, as the load increases, speed is going to decrease. So back EMF is going to decrease. So because of the back EMF decrement, answer is B. Next, DC series motors are best suited for traction because torque is proportional to the square of the armature current and speed is proportional to the torque. No, speed is not going to proportional to the torque. This is wrong. So option A is wrong. Torque is proportional to the square of the armature current, correct, and speed is inversely proportional to the torque. This is correct. Torque and speed both are proportional to the square of the armature current. No, this is wrong. So answer is B. DC compound motors are usually DC compound motors are cumulative compound motors only. Because why not differential compound motors means we know N proportional to EB by pi. So in case of differential compound motor, total flux is equal to pi SH minus pi SE. So as the load increases, series field winding flux is going to increase. This is going to increase. This total flux is going to decrease. So total flux decreases means speed is going to increase. So as the load increases, speed is going to increase. In differential compound motor, as the load is increasing, speed of the motor is going to increase. So this is a dangerous feature. So usually we don't use these motors. We use only cumulative compound motors. When the supply terminal of the DC shunt motor are interchanged, then motor will run its normal speed in the same direction as before. The direction of the rotation will reverse. Motor will run much faster in the same direction. As supply terminals are reversed and motor is going to run its in the same direction, it will be running in the same direction because field current direction will be reversed and armature current direction will be reversed. So the torque will be same, positive only, unidirectional only. Motor will run in the same direction. Next, in a DC series motor, torque developed is inversely proportional to the armature current. No, it's not correct. In series motor, T proportional to what? Ia square. Directly proportional to the armature current, not correct. Proportional to the square of the armature current, this is correct. Proportional to the square root of the armature current, wrong. So answer is C, T proportional to Ia square. Next, the horsepower obtained from the motor shaft is that is bhp, brake horsepower. Answer is B. The speed of the 4-pole DC series motor at no load. Whatever may be the pole, series motor at no load, it is going to be infinite speed. Answer is C. Dangerous speed. N proportional to EB by pi. Under no load condition, the series motor pi becomes very low, and denominator is low means total speed will be dangerous speed. Which of the following DC motors will have the highest percentage increase of input current for the same percentage increase in the torque? Which of the following DC motors will have the highest percentage of increase of input current for the same percentage of increase in the torque? So in case of shunt motor, we need more current for the increment in the torque. So we have linear relationship T proportional to Ia. So answer is B. In a DC motor, unidirectional torque is produced with the help of brushes as well as commutator. Answer is D. Next, the counter EMF nothing but what? Back EMF of a DC motor. It is useful in the conversion of electrical energy into mechanical energy. Answer is C. Next, the mechanical power developed by the armature of DC motor is equal to the mechanical power developed by the armature. Mechanical power means mechanical power is developed in the armature means power is equal to what? Voltage into current. So mechanical power developed in the armature. Armature voltage, in the armature voltage is EB, current is nothing but what? Ia. So EB into Ia. So armature current multiplied by back EMF. Answer is A. Next, the induced EMF in the armature conductor of a DC motor is, in the DC motor armature conductors, induced EMF is AC, that is in what shape it will be sinusoidal. Answer is A. The electric machine which will have high efficiency when we will have the high efficiency whenever we have the low losses. So answer is whenever losses are low, we'll be having the high efficiency. An electric motor in which rotor and stator fields rotate simultaneously. If stator and rotor both are rotating simultaneously, that motor is called synchronous motor. So thank you. This is about the DC motors. So remember, in DC motors, one diagram I'll draw here in DC motors, so that you can draw all other diagrams also. So in DC motor we have DC shunt motor, DC series motor and DC compound motor. So I'll draw DC series motor. Let us say motor also will have armature winding as well as field winding. This is armature winding, and motor means back EMF EB. Motor armature winding resistance is RA, and field winding, series field winding means less number of turns, less resistance. As it is a series motor, field winding must be connected in series with the armature winding. So as it is a motor, we have to give the power supply. Input power supply is what? V, and this is line current, and current flowing through series field winding is ISC. Current flowing into the armature is called what? IA. As current is entering at the top, this is plus and it is minus, and current is entering here plus and it is what? Minus, and this is plus and it is minus. So this is a circuit diagram of DC series motor, and IL is equal to ISC is equal to IA, because series field winding and armature winding both are connected in series, therefore same current will be flowing. And to develop the relation between the voltages V comma EB, we have to apply the KVL. I am applying the KVL in this direction. I am coming across negative polarity first, minus V, and I am coming across positive plus ISE into RSE, and I am coming across plus first plus EB. So plus voltage drop in the armature winding is IARA. Voltage drop in the brushes is VBD is equal to 0. If I neglect the voltage drop in the brushes, VBD becomes 0. And ISC and IA both are same. That I am taking as IA. So minus V plus IARA plus ISC into RSC plus EB is equal to 0. This ISC is also equal to what? IA. Then this minus V will come here. V is equal to EB plus IA is taken common here. IA into RA plus RSC. So in this manner we will construct the diagrams for series motor, shunt motor. In shunt motor, very simple. Instead of this field winding coming over here, it will come, shunt field winding will come here. This is nothing but what? Shunt field winding, shunt motor. Okay, so this is about the DC motors practice questions. And always remember these formulas: T proportional to pi Ia, speed equation N proportional to EB by pi, armature current Ia is equal to V minus EB by RA, and EB is equal to V minus IA RA, and the torque equation is 0.159 pi Ia Pz by A. This is a torque equation of DC motor, very important. And output power of the motor in terms of torque 2 pi Nt by 60. Right? So these are the very important formulas. Thank you. In the next video, we'll discuss the few practice questions on transformers.